Welcome to the Explainer. Today, we're jumping into the one language that pretty much powers every database you've ever touched, whether you knew it or not. We're talking about SQL.
Okay, so let's get right into it. Think about it. We're living in a world with so many different database systems. You've got Oracle, Microsoft SQL Server, MySQL. The list goes on and on. So with all these different systems, how in the world do they talk to each other?
This is the exact problem that SQL was created to fix. I mean, can you imagine the chaos if there wasn't a common standard? Every developer, every data analyst would have to learn a totally new language for every single database they worked with. It would be a nightmare.
And the solution, of course, is SQL. You can think of it as the ultimate universal translator, the lingua franca for relational databases. It's the one language they all agree to speak, which lets us ask for information in a way that's consistent and predictable. But how did it get to be the global standard in the first place?
So how did this standard even happen? Well, SQL didn't just pop up out of nowhere. Its status as the global standard was actually the result of a really deliberate, years-long process driven by international standards organizations.
What's so cool about this timeline is that it shows this whole thing was no accident. It was a consistent international push to build and maintain this standard. It started back in the 80s, which led to that landmark SQL 92 release. That became the benchmark for basically every major database out there, and it's still being updated even today.
All right, so if SQL is a language, what does a simple sentence even look like? Well, it all boils down to this incredibly powerful three-part structure that's really the backbone of almost any data query you're ever going to write.
So the most common thing you'll ever do with SQL is just ask the database for some specific information. We call that a query. And it's almost always done with this select from where framework. It's basically like telling someone exactly what you want, where to get it from, and any special conditions. It starts simple. First, you tell it what columns you want to see using select, and then where to find those columns using from. So right here, we're telling the database, hey, get me the department and buyer columns from the table called SKU data. Simple enough, right? But that's not quite the full story. See, we usually don't want everything in the table, so we add a where clause to filter our results down. And this is where the real magic happens. By adding where department equals water sports, we're not just getting data, we're asking for a very specific slice of that data. And just like that, you've built a complete, really targeted query. And boom, here's what you get back. Now notice how the database did exactly what we asked. It selected only the department and buyer columns, it looked in the right table, and, this is the crucial part, it filtered it to show only the water sports entries. That's the power of that simple little framework.
Now this brings us to something that trips up a lot of people when they're learning SQL. If it's supposed to be a standard, why does code that you write for one database sometimes just completely fail in another one?
The answer is dialects. While the core language is totally standardized, different database companies have added their own little extensions and variations over the years. Honestly, the best way to think about it is like spoken language. They all understand the basic grammar, but each one has its own slang and its own accent.
So these little syntax differences are a huge deal. Take wildcards, for example, which you use for pattern matching. The official SQL 92 standard uses a %sign. But if you're using an older version of Microsoft Access, it uses an asterisk to do the exact same thing. It's a tiny difference, but trust me, it'll break your code if you're not aware of it.
And here's another classic example, putting text together. If you want to join strings in Microsoft's T-SQL dialect, you use a plus sign. But if you're over in Oracle's PL/SQL world, you have to use these double pipes. The goal is totally identical, but the syntax, the dialect, is different.
Okay, so you know the language, you know there are different dialects, but how do you actually use it? How do you send these SQL commands to a database? Well, you don't just type them into a Word doc. You have to use a specific piece of software, often called a client, that's built for that specific database system. And as you can see, every major database company has its own tool for the job. Now, the SQL you write inside these tools is going to be like 95% the same. But the user interface, the special features, that's where they really differ. The most important thing to remember is that they all give you a window where you can speak SQL directly to the database.
Which really brings us right back to the main idea here. When you get right down to it, despite all the different tools and all the different dialects, SQL's role as the universal standard is what makes all of modern data processing possible. It's the common ground. It's the one language they all understand, and that's what lets data flow between all these countless systems.
But
Looking ahead, the data world is always changing. We're seeing the rise of these non-relational databases. You've probably heard them called NoSQL, and the massive challenges of big data. It makes you wonder, right? Is SQL's reign as the king of data languages guaranteed forever? Or are we maybe seeing the very beginning of the next big evolution in how we talk to our data?
Hey, if you found this explainer helpful, it'd be awesome if you could hit that like button, share it with someone who might be interested, and subscribe for more deep dives into the tech that shapes our world. Thanks for joining us.